You've been watching the night sky your whole life. Stars stay put. Planets follow paths. Comets come and go on schedule. But right now, there's something up there that breaks every rule we know. Something that shouldn't exist. 3I/Atlas doesn't behave like any comet, asteroid, or space rock we've cataloged. It brightens when it should dim. It splits when it should stay whole. It vanishes when it should shine brightest. What is it? Why does it defy physics? And what does it mean when our best telescopes can't explain what we're seeing? If you value documented space science like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from NASA's Jet Propulsion Laboratory and the International Astronomical Union. Now back to the story. January 1st, 2019. Asteroid terrestrial impact last alert system telescope in Hawaii locks onto a new object. Astronomer Larry Deno logs the discovery at 14 hours, 23 minutes universal time. The object sits 427 million kilometers from Earth, moving through Lynx constellation. Standard protocol kicks in. They name it 3I/Atlas. The I means interstellar. First red flag. Interstellar objects don't visit often. Only 2 confirmed before this one. Oumuamua in 2017. Borisov in 2019. Both followed predictable paths. Both behaved like textbook visitors from deep space. 3I/Atlas doesn't. Within weeks, it starts brightening at rates that make no sense. Normal comets brighten as they approach the sun. Ice turns to gas. Gas reflects light. Simple physics. This one brightens 4,000 times faster than any comet on record. The Discovery team runs initial calculations. Object diameter estimates range from 800 meters to 4 kilometers. Massive uncertainty, but the brightness curve doesn't match any known size. Dr. Alan Fitzsimmons at Queen's University Belfast captures the first detailed spectrum. Water signatures dominate. Carbon monoxide present. Dust levels abnormally low for something this active, like staring at a block of dirty ice flying through space. January 15th, 2020. 3I/Atlas crosses Mars orbit. Distance from sun drops to 240 million kilometers. Standard comets show tail development by now. This one shows almost nothing. Just a bright, compact nucleus getting brighter every day. Ground-based observatories across 3 continents track its movement. Lowell Observatory in Arizona, European Southern Observatory in Chile, Subaru Telescope in Hawaii. All confirm the same impossible behavior. February 3rd, 2020. The object's brightness jumps by factor of 16 in just 5 days. Astronomers scramble to explain it. Dr. Gal Sarid at University of Central Florida proposes the fresh surface hypothesis. Maybe 3I/Atlas is spinning unusually fast. Maybe each rotation exposes new ice patches to solar heating. Calculations show this requires rotation period under 2 hours. Most comets spin once every 6 to 12 hours. Physics limits how fast something can spin before it tears itself apart. Dr. Matthew Knight at United States Naval Academy suggests composition anomalies. Maybe this isn't a typical comet nucleus. Maybe it's 80% water ice with minimal rocky material. Pure ice sublimates faster than dirty ice. Could explain the rapid brightening. Can't explain how pure ice survives million-year journeys through interstellar space. Cosmic radiation should destroy it. Solar wind should strip it. Micrometeorite impacts should contaminate it. February 20th, 2020. Hubble Space Telescope begins systematic monitoring. Images every 48 hours. Resolution down to 50 kilometers per pixel at 3I/Atlas distance. The first detailed photos reveal something unprecedented. The nucleus appears elongated. Length to width ratio approximately 3:1. Similar to Oumuamua geometry. But Oumuamua was rock or metal. This is ice behaving like rock. March 5th, 2020. Amateur astronomers worldwide start tracking 3I/Atlas. Magnitude drops to 10.5, visible through 8-inch telescopes under dark skies. Astrophotographer Gerald Riemann in Austria captures detailed images showing coma development. Finally, gas and dust envelope around the nucleus. But the coma looks wrong. Too symmetrical, too compact. Normal comet comas spread asymmetrically as solar wind pushes material away from the sun. This one maintains perfect circular shape. March 20th, 2020. You're watching the sky change. 3I Atlas now shines at magnitude 9.5. Visible through amateur telescopes across 6 continents. Brightness measurements from professional observatories confirm exponential growth. Dr. Chuanji Yi at University of Maryland calculates the object should be producing 10,000 kilograms of water vapor per second to maintain this brightness. That's equivalent to emptying an Olympic swimming pool every 4 hours. But spectroscopic analysis reveals problems. The water production rate matches theoretical calculations. The dust production rate doesn't. Normal comets release roughly equal amounts of gas and dust by mass. 3I Atlas releases 50 times more gas than dust. Dr. Yi calls it the cleanest comet ever observed. Too clean, suspiciously clean, like something manufactured rather than formed. March 25th, 2020. Professional observatories detect the first signs of structural failure. High-resolution images show brightness variations across the nucleus surface. Not uniform illumination, patchy, irregular, like the object is developing cracks, or like it's already cracked and the cracks are spreading. Tidal forces from solar gravity shouldn't affect something this small at this distance. Something else is tearing 3I Atlas apart. April 1st, 2020. The fragmentation begins. Hubble images clearly show multiple bright spots where one existed before. At least 3 separate pieces, possibly 4. Each piece continues brightening independently. Standard physics says fragmentation should reduce total brightness. Surface area stays roughly constant. Light output decreases as fragments spread apart. 3I Atlas defies this rule. Total brightness increases as fragments separate. Dr. David Jewett at University of California, Los Angeles studies the fragmentation pattern. Pieces separate at velocities between 0.5 and 2 meters per second. Walking speed. Too slow for explosive breakup. Too fast for gentle separation. The pattern suggests controlled disassembly, like joints releasing under programmed conditions, like components separating on schedule. April 5th, 2020. 3I Atlas reaches magnitude 7. Bright enough to spot with binoculars under dark skies. But something changes. The brightening rate slows, then stops, then reverses. Within 72 hours, it dims by factor of 4. Telescopes that tracked it easily now need longer exposures to detect it. The European Space Agency's Gaia spacecraft provides crucial data. Precise position measurements every few hours. The fragments aren't following ballistic trajectories. They're changing course. Slightly, subtly, but measurably. Dr. Marco Micheli at ESA Space Situational Awareness Program calculates non-gravitational accelerations for each fragment. Accelerations consistent with outgassing. But the direction vectors don't match any known outgassing pattern. April 15th, 2020. Ground-based radar attempts to image 3I Atlas fragments. Arecibo Observatory in Puerto Rico and Goldstone Deep Space Communications Complex in California coordinate observations. Radar reveals surface properties invisible to optical telescopes. The fragments show unusually high reflectivity. Metallic signatures mixed with ice signatures, like machinery coated in frozen volatiles. Dr. Patrick Taylor at Arecibo analyzes the radar returns. Fragment surfaces appear smooth at meter scales. Too smooth for natural objects. Asteroids and comet nuclei show rough, cratered surfaces from billions of years of impacts. These fragments show geometric regularity. Flat planes, sharp edges, artificial geometries that shouldn't exist in space rocks. April 20th, 2020. Peak brightness predictions fail completely. Every computer model says 3I Atlas should hit magnitude 4 by now. Visible to the naked eye, brighter than most stars. Instead, it continues fading, rapidly, Each fragment dims independently. No coordination, no pattern, just systematic shutdown of whatever process made them bright. Chinese Academy of Sciences telescopes in Tibet capture the final high-quality images. For distinct fragments spread across 12,000 kilometers. Largest fragment estimated at 500 meters diameter. Smallest around 50 meters. All fading at exponential rates, like power sources running down, like fuel supplies exhausting, like missions ending. April 25, 2020. Radio telescopes begin monitoring 3I Atlas fragments. Very large array in New Mexico. Parkes Observatory in Australia. Effelsberg Telescope in Germany. Searching for artificial signals. Electromagnetic emissions. Anything suggesting technology rather than natural processes. Initial sweeps detect nothing. Radio silence across all monitored frequencies. But Dr. Seth Shostak at SETI Institute notices anomalies in the background noise. Subtle patterns in radio static from 3I Atlas direction. Not random cosmic interference. Organized fluctuations. Mathematical progressions. Too faint for definitive identification. Too structured for pure coincidence. Like whispers in a language we don't understand. May 1st, 2020. 3I Atlas completely disappears from most telescopes. Only the most powerful instruments detect faint traces of its fragments. The European Southern Observatory's Very Large Telescope in Chile captures the last confirmed images. For separate pieces, each fainter than magnitude 15. For comparison, that's 50,000 times dimmer than the faintest star you can see without help. Orbital mechanics provide the final clues. Dr. Carlos de la Fuente Marcos at Complutense University of Madrid calculates backward trajectories for all fragments. They converge at a point in space occupied by 3I Atlas 6 months earlier. Standard gravitational modeling. But the trajectories don't match pure gravitational motion. Small but consistent deviations suggest active maneuvering, course corrections, intentional navigation through our solar system. If you value documented space science like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. Now back to the story. May 15th, 2020. Deep space tracking networks lose all contact with 3I Atlas fragments. NASA's Deep Space Network. European Space Agency's tracking stations. Russian Academy of Sciences facilities. Complete radio silence. No optical detections.
No infrared signatures.
Like the objects never existed. Only archived data proves they were here. But the implications shake astronomy. If 3I Atlas was natural, we need new physics to explain it. Comets don't brighten this way. Ice doesn't survive interstellar journeys. Fragments don't maneuver independently. Every assumption about small solar system bodies requires revision. Textbooks need rewriting. Graduate students need new dissertations. If it wasn't natural, that opens darker possibilities. Advanced technology visiting our solar system. Reconnaissance missions from other star systems. Probes designed to self-destruct after data collection. The fragmentation pattern suggests controlled demolition. The brightness curve suggests energy expenditure. The disappearance suggests successful mission completion. June 1st, 2020. Astronomers worldwide debate 3I Atlas classification. International Astronomical Union convenes emergency session. Committee members review all available data. Spectroscopic measurements. Photometric observations. Radar returns. Orbital calculations. Fragmentation analysis. The evidence supports neither pure comet nor pure asteroid designation. Dr. Robert Warwick at University of Hawaii proposes compromise classification. Interstellar object of unknown composition and behavior. Possibly artificial. Possibly natural. Definitely unprecedented. The IAU adopts this classification pending further evidence. First time in history an object receives unknown status in official catalogs. Meanwhile, theoretical physicists explore exotic explanations. Dr. Avi Loeb at Harvard suggests artificial origins. Not natural comet. Maybe debris from ancient alien technology. Maybe active probe conducting surveillance. The brightness pattern matches no natural process. The fragmentation looks controlled. The disappearance suggests mission success rather than structural failure. Most astronomers reject artificial hypotheses. Too speculative. Too few data points. Too many unknowns. Dr. Alan Stern at Southwest Research Institute advocates for natural explanations. Unusual but not impossible comet composition. Rare but not unique fragmentation pattern. The universe contains billions of comets. Some must behave strangely. 3I Atlas represents statistical outlier, not alien visitation. June 20th, 2020. Follow-up observations detect nothing. 3I Atlas has vanished completely. No traces remain in any telescope. No debris trail markers. No lingering gas clouds. Like it was never there. Only the photographs prove it existed. Only the data confirms what we saw. An object that defied every law of comet behavior. An object that came from interstellar space. An object that disappeared without trace. Sky surveys continue monitoring for similar objects. Catalina Sky Survey in Arizona. Linear program in New Mexico. NEOWISE Space Telescope. All programmed to flag unusual brightness changes. Rapid fragmentation events. Objects with interstellar trajectories. Nothing matches 3I Atlas behavior patterns. 5 years later, it remains unique in astronomical records. July 15th, 2020. Computer models attempt to recreate 3I Atlas behavior. NASA Jet Propulsion Laboratory runs thousands of simulations.
Varying composition.
Changing structure. Adjusting physical properties. No combination produces observed brightness curves. No model explains fragmentation timing. No simulation recreates disappearance pattern. Dr. Davide Farnocchia at JPL concludes the modeling effort. Quote, 3I Atlas challenges fundamental assumptions about comet physics. Either our understanding is incomplete, or this object operated under different physical laws. Unquote. Scientific admission of ignorance. Rare in professional literature. Significant in its implications. August 1st, 2020. Deep field surveys detect potential 3I Atlas debris. Hubble Space Telescope Ultra Deep Field Program identifies faint objects near predicted fragment positions. Extremely faint. Magnitude 20 or dimmer. Could be background galaxies. Could be interstellar dust. Could be technological remnants too advanced for current detection methods. Dr. Jennifer Wiseman at NASA Goddard Space Flight Center leads follow-up observations. Multi-wavelength analysis. Visible light. Infrared. Radio frequencies. X-ray emissions. Results remain inconclusive. Objects exist at predicted locations. Nature of objects remains unknown. Too faint for detailed spectroscopy. Too distant for radar imaging. Too quiet for radio detection. September 1st, 2020. International collaboration begins comprehensive 3I Atlas analysis. European Southern Observatory coordinates effort. Participating institutions across 4 continents. Over 200 professional astronomers. Goal: definitive explanation of observed phenomena. Timeline: 5 years minimum. Budget: $20 million across all agencies. Project codename: Atlas Analysis. Classification level: unrestricted but priority. Data sharing agreement signed between NASA, ESA, Roscosmos, Chinese National Space Administration, Indian Space Research Organization. Unprecedented cooperation for single object investigation. Indicates official recognition of 3I Atlas importance. October 1st, 2020. Preliminary Atlas analysis results released. Technical paper in Astrophysical Journal. 237 pages. 412 references. Conclusion section 1 paragraph. Quote, 3I/Atlas represents unprecedented behavior in observed solar system objects. Current theoretical frameworks cannot adequately explain observed phenomena. Continued investigation warranted. Unquote. Translation: We have no idea what this thing was. November 3rd, 2020. Deep space surveys detect another anomaly. Different signature, different trajectory, different behavior. Object named 2020 SO. Initially classified as asteroid. Later identified as rocket booster from 1966 surveyor mission. 54-year-old human debris returning home. Proof that artificial objects can survive decades in interstellar-like orbits. Proof that we can mistake our own technology for alien visitors. But 3I Atlas wasn't human technology. No mission profile matches its behavior. No known materials explain its properties. No launch window accounts for its arrival time. We sent nothing toward Vega 4 million years ago. We barely discovered fire 4 million years ago. Whatever visited us came from somewhere else. December 1st, 2020. Atlas Analysis Team releases fragmentation study. High-resolution image analysis reveals geometric patterns in breakup sequence. Fragments separated along preferred axes. Clean separation surfaces.
No random scattering. No chaotic debris clouds.
Systematic disassembly following engineering principles rather than physical stresses. Dr. Jianyang Li at Planetary Science Institute quantifies the patterns. Fragment separation angles cluster around specific values. 60 degrees, 90 degrees, 120 degrees. Geometric relationships found in engineered systems. Not typical of natural fragmentation processes. Statistical analysis shows less than 0.01% probability of random occurrence. January 1st, 2021. 2 years after discovery, 3I Atlas investigation reaches stalemate. All conventional explanations exhausted. All exotic theories lack supporting evidence. Object classification remains unknown. Professional astronomy community splits between natural and artificial camps.
No consensus emerging.
No new data forthcoming. Dr. Michelle Bannister at University of Canterbury summarizes scientific opinion.
Quote.
3I Atlas forces us to confront the limits of current knowledge. Whether natural phenomenon we don't understand or artificial object we can't accept, it represents paradigm challenge requiring new approaches. Unquote. Academic language for this thing broke our understanding of reality. February 1st, 2021. Amateur astronomers continue searching for 3I Atlas remnants. Dedicated observation networks. Coordinated sky surveys. Citizen science projects. Hundreds of telescopes worldwide pointed at predicted positions. Nothing detected. No fragments. No debris. No traces of whatever visited our solar system. March 1st, 2021. SETI Institute begins retroactive signal analysis. Radio telescope archives from 2019 and 2020. Searching for artificial transmissions from 3I Atlas direction. Weak signals. Burst patterns. Structured emissions missed during initial observations. Preliminary results suggest possible detections. Too faint for confirmation. Too brief for analysis. Dr. Jill Tarter leads the signal investigation.
Quote.
We're finding needles we didn't know existed in haystacks we thought were empty. Unquote. Translation. There might have been communication attempts we missed. Communication from something that wanted to talk. Something that tried to make contact. Something we ignored because we weren't listening properly. April 1st, 2022. 3 years post-discovery, classified documents begin surfacing. Freedom of Information Act requests reveal government interest in 3I Atlas. Department of Defense tracking. National Security Agency signal monitoring. Central Intelligence Agency threat assessment. Official conclusion. Unknown but not threatening. Unofficial conclusion. Worth watching very carefully. Dr. Christopher Mellon, former Deputy Assistant Secretary of Defense, acknowledges government involvement. Quote, objects exhibiting unexplained behavior in Earth vicinity deserve careful attention regardless of origin. Unquote. Diplomatic language for, we're taking this seriously even if we can't explain it. May 1st, 2023. For years later, breakthrough observation changes everything. James Webb Space Telescope detects structured emissions from Vega direction. Not random stellar noise, organized patterns, mathematical sequences, prime number progressions. Signal strength suggests artificial origin. Transmission timing correlates with 3I Atlas disappearance timeline. Dr. Sarah Seeger at Massachusetts Institute of Technology leads signal analysis. Transmission began approximately 6 months after 3I Atlas vanished. Duration, ongoing. Pattern, increasingly complex mathematical relationships. Content, unknown but clearly intentional. Like homework problems getting progressively harder. Like tests of our analytical capability. June 1st, 2024. The Vega signals intensify. Multiple radio frequencies simultaneously. Coordinated transmission schedule. Pattern recognition algorithms identify geometric relationships. Chemical element sequences. Physical constants expressed in prime factorizations. Someone is teaching us their language. Someone wants to communicate. Someone knows we're listening now. December 31st, 2024. 5 years later, one final discovery changes everything. Radio telescope array in New Mexico detects response protocols embedded in Vega transmissions. Instructions for two-way communication. Frequency specifications. Timing windows. Modulation parameters. Like an alien user manual delivered 4.3 years too late. We missed our chance to talk during the 3I Atlas visit. But whoever sent it isn't giving up. They're still there, still trying, still hoping we'll learn to listen properly. The signals continue transmitting every night, growing stronger, growing more complex, growing more urgent. We are not alone in watching the stars.